Hi, my name is Shuo Wang. I'm a PhD candidate student in CPAS. In this video, I will briefly introduce our work in the 48-volt output LLC converter for wide bandgap device-based data center and telecom power supply. The 48-volt power supply is composed of EMI filter, PFC, and LLC DC-DC converter for conventional fixed DC-link voltage structure. The output voltage is regulated by LLC DC-DC converter, with output voltage from 40 to 60 volt. The switching frequency is varied in a large range, especially for VO equals 40 volt at light load. In this research, we propose to use the variable DC-link voltage, and this can help to shift the regulation burden from DC-DC to PFC. Therefore, the LLC converter can always work at resonant frequency to achieve the highest efficiency. The four elemental transformers can be integrated into a single magnetic core by means of flux cancellation. Take two elemental transformers as an example. Here shows the flux inside the round-shaped leg and the primary side winding current direction. If we rotate these two cores by 90 degrees, the flux in the center leg can be cancelled, and in this way we can integrate the two elemental transformers into a single core. The same integration process can be done for transformer 3 and 4. After that, we can further mold them together and integrate 4 transformers into a single magnetic core. However, in this way, the flux inside the core is Phi-B and are unevenly distributed. By further rotating the lower two legs with 180 degrees, the flux inside the core can be reduced to half Phi-B. By doing this, the flux density and core loss can be reduced. This page shows how we design the transformer winding with 3:1 turns ratio in a 4-layer PCB. For the high output current application, we generally use 2 layers to share the high secondary side current in order to reduce winding loss. Take leg 1 as an example. The parallel secondary winding are in layer 1 and layer 4. The first turn of primary winding is in layer 2, and the second turn of primary winding is divided into 2 half IP turns. One is in secondary layer and another one is in the third layer. The final primary turn is arranged in the third layer. We also show the magnetic motive force in here. In this way, we can achieve 3:1 turns ratio with 4-layer PCB for high output current applications. A 3 kW, 500 kHz wide bandgap device-based LLC converter has been built up. The power density is 24.4 kW per liter, and the peak efficiency is almost 98.5%. These are the magnetic components for the proposed matrix transformer. This is the prototype of our 3 kW, 48 volt LLC converter. The footprint is 3.8 by 2.7 inch square, and the height is 0.6 inch. We use a 1000 volt silicon carbide MOSFET from Cray in primary side, and 80 volts GaN device from EPC in secondary side. This is the heavy load steady state waveforms. Channel 1 shows the drain source voltage of silicon carbide MOSFET. Channel 2 and Channel 3 shows the gate source voltage of silicon carbide MOSFET. And Channel 4 shows the resonant current. Thanks for watching this video.